The stars that slide across our heavens have for millennia inspired both awe and fear. But it won't be the stars that bring disaster. That will come from the comets and asteroids that careen through space and smash into our planet. These collisions have modeled our past and will shape our destiny.
Well, we're talking about a natural hazard that's capable of wiping out human civilization or even the human species. So now that we have the capability to look and see if there's something threatening, we should look.
Every day, billions of tiny alien invaders bombard the Earth. They're fragments of asteroids and comets. Most of this fallout is no larger than a pinhead, but once every century, there's an assailant big enough to wipe out an entire city. Every 50 million years, there's an invader big enough to wipe out entire species. The last big one was 65 million years ago. We're long overdue for our next big impact. Our moon is also a target. Its surface has been pummeled since birth by a barrage of space debris. Through the eyes of the Clementine spacecraft, we see a face permanently scarred. The sun takes responsibility for the battering that Mercury receives, for its tremendous pull sucks in these missiles. And little Mercury, innocent bystander, is caught in the line of fire. Space still holds a stockpile of ammunition, and the destructive power of comets was recently felt by Jupiter when fragments of Shoemaker-Levy 9 smashed into the planet. Had Earth been their target, each fragment would have devastated an area the size of Texas. Eugene Shoemaker, who gave his name to Shoemaker-Levy 9, needn't always look millions of miles into space to see such collisions. He knows that Earth, too, is a sitting duck, and his detective work uncovers evidence of terrestrial hits.
Well, I've been looking at this feature for more than 30 years, and I knew from observations at the telescope of the asteroids that are out there in space near the Earth and that could hit the Earth, and I could calculate how often they actually strike the Earth.
He knows the Colorado Plateau like the back of his hand.
And I knew the average age of the beds exposed.
He figured that there should be a crater
somewhere on the Colorado Plateau, and you couldn't hide it.
And he couldn't understand how he could have missed it.
And then I said, Shoemaker, you dummy, you've only been looking at it for 30 years.
And luckily, I walked into his office a week later, and he said, let's go look at this thing.
I came back out here with a young graduate student from Caltech, and we said, if this is an impact crater, there have to be faults around the outside. And we looked over the canyon, and bam, there they were. You could see them. They are obvious as the nose on your face. These faults are formed when the initial cavity that's excavated by the impact collapses, and then the rocks all the way around on the outside just slump in toward the original crater.
Now just a deep crater, this area was once utter devastation.
The energy of the asteroid that struck here is equivalent to the energy released if one were to detonate all at one time about half the nuclear weapons of America.
A relatively recent strike in Arizona forms Meteor Crater.
We have very good geologic evidence for the bombardment of the Earth by asteroids and comets in the past. There are more than 150 craters like this one that we've found so far on the Earth.
Wolf Creek in Australia, half a mile across, the rim thrown out when the missile struck is perfectly preserved. Gosses Bluff, 140 million years old and worn by weather. Henbury, a cluster of craters shows the projectile broke into pieces just before impact. Out there in the unstable wilderness of space, there's a variety of impactors. Any one of them could be a crater maker. There are asteroids, chunks of rock and metal up to 600 miles across. They form the asteroid belt orbiting between Mars and Jupiter. Smaller and more numerous are comets, muddy ice balls up to 60 miles across. They throw out tails millions of miles long as they near the sun. Comets come from the Oort cloud at the furthest edge of the solar system. Meteors, the fireworks when any small space debris is incinerated on entry into our atmosphere. They've picked up the name shooting stars, but in reality they have nothing to do with stars. Occasionally, a larger fragment of comet or asteroid will skim across the sky as a fireball. Captured on home video, this flaming trail is an invader being counterattacked by the friction of the Earth's atmosphere. The fireball is melted and broken apart by the encounter. But sometimes the breakup is violent. Trees were blown outward by the blast from a fireball explosion 5 miles above the Tunguska River in Russia in 1908. 20 years later, the forest still tells of the day when the sky exploded. Occasionally, our atmospheric armor is pierced. Sikote Alin, also in Russia, 1947. A space missile has penetrated Earth's defenses. Lumps up to 1.5 tons are just part of the 70 tons of iron that survived the Inferno passage from heaven to Earth. They struck the ground with such force that they lodged 26 feet below the surface. Once landed, these fragments are called meteorites, and some look out of this world. Meteorites have been falling to Earth since Genesis. Metal meteorites may well have been man's first source of iron. Ancient axes, scythes, and spears could all have been fashioned from off-world metal whose origins lay 1 billion miles away. Some may even have become early weapons of war. In ancient Egypt, a pyramid-shaped meteorite placed atop a tall stone pillar may have inspired the pointed design of the Egyptian obelisks or even the pyramids. The metal meteorites can be fashioned into trinkets and mementos. Meteorite belts and meteorite daggers. Meteorites may be the secret of the Sudbury mine's lode. In Ontario, they're drilling for nickel in what some think is a buried asteroid. Meteorites really may be pennies from heaven. A beautiful shooting star streams across the night sky. In New York State, a 27-pound remnant falls on the trunk of a car. Adversity turns to advantage. $59,000 is offered for the meteorite. and $10,000 for the car. But that's chicken feed. These 3 stones in a New York City auction house may not look like $1 million, but that's a fair estimate of their worth. Just like their origins, meteorite prices can be astronomical. Robert Hutchison appreciates that the rocks on sale tonight are exceptional.
The 3 meteorites that are up for auction, they're very different from the bulk of meteorites, and we have evidence, very strong evidence, that they came from the planet Mars. The first one, Chassigny, it fell in France in 1815. It's called Chassigny because meteorites are named after places near where they land. The second meteorite fell in northern Nigeria, near a place called Zagami. And the third of the meteorites fell as a shower of stones in Egypt. In one case, the stone was broken up and destroyed. The people didn't like this thing that fell from the sky.
But how can we be sure that these stones are indeed of Martian origin?
NASA landed 2 spacecraft on Mars, and each of them measured the composition of the Mars atmosphere on the way in. And the Zagami meteorite proved to have trapped gases that match the Mars atmosphere.
3 stones that fell to Earth, and that makes them very special for someone like Robert Haig. Dealing in meteorites has won and lost him thousands of dollars. For Haig, this is serious business. Beneath his house is his life's work. His basement is an Aladdin's cave. Within these vaults lie 1,000 fragments of other worlds. Some may be bought, others he would never sell.
Certain meteorites are sold by the pound, other meteorites are sold by the carat. Normally, meteorites go for about the same price as silver. Many meteorites are sold around the price of gold, and other meteorites like the Mars rocks and the Moon rock are much more expensive than diamonds.
Haig values his Martian meteorite at around $60,000 per ounce, making this chunk worth about $6 million. If you can't afford a whole meteorite, then you can buy a part. Dicing and slicing is part of the business. Haig's not just a dealer trading other people's labor. In search of his commodity, he's prepared to risk his neck.
I found the best way is to go to places where meteorites have fallen before, know what you're looking for, and then search in that area. Because you know they found them there before, there should be a few more that they missed. And another way is to go to dry desert areas where there's no grass and no rocks and try to find rocks or stones in these areas, because they had to have fallen there. There's no other way they would have got there.
Robert Haig and his partner Heidi scan the Arizona desert for chunks from the heavens. And from his bird's eye view, he scours the ground.
Heidi, do you read me? Copy.
I read you.
Well, I saw a couple things here. I'm going to turn around and come back and check. Black rock down there. I'm hoping, keeping my fingers crossed. Can you come over here and meet me?
You come in first, and I'll meet you there.
Check this out.
More often than not, they find nothing but common pebbles.
Just a piece of steel, I think.
Like prospectors, they're looking for the big strike. One find can make all the difference.
The Corvette was purchased by selling a piece of Mars rock. When Bob first got the Mars rock, he was able to sell a portion of it to another collector, and that first turnaround of cash from the piece of Mars rock went directly to pay for the Corvette, and he bought it outright.
Fallen moon rock has also been good to Haig. He paid $60 for a piece now worth about $1 million.
You know, collecting meteorites has been a full-time hobby and passion and work for me for the last 20 years. I risked my life, I risked my money, I risked my well-being all over the planet in many different godforsaken places.
He's always ready to go look for a meteorite. He's got passport, money, backpack, and he'll go in the next 5 minutes if something new falls.
Well, searching for meteorites has gotten me in trouble a few times. At one place in particular, we were down in Argentina. I was trying to buy one of the largest meteorites in the world down there, 37 tons. Turned out the guy who said he owned it wasn't the real owner. They said it's a national treasure. The police came with machine guns and put us all in jail for a few days, but it wasn't so bad. It turned out we were released within a week. Lost some money, but overall it was a great adventure, and hey, at least we tried for the big ones, right?
Hay can spot a meteorite at 20 paces. Often he uses a metal detector, but it's given him his share of false hits.
Some wire.
As well as his own, he'll deal with finds other people have unearthed.
They'll drive all the way from across the states, show up at our front door, and here's a big rock, and they're all excited, and I open the trunk, and I go, oh man, I'm sorry, this is not a meteorite. And there's three things. First, they get really mad at me. They say, Grandpa saw it fall, you calling my grandpa a liar? Next thing, no peace, man, it's cool. Next thing, they get mad at each other. They start crying and screaming, I told you not to do it. Third thing that always happens, they ask me if I still want to buy it. The idea here is to get everybody on Earth trying to find these meteorites. Because researchers, scientists, chemists, we need these things to study.
Hey, Dr. Crane. I was out hiking yesterday and I found this rock.
Geologist
It's really heavy,
David
and
Kring
it's really
appreciates
heavy.
every new find. He too has optimistic hunters.
Yeah, the rest of the rocks were like gray and pink.
Well, it is really heavy, and iron meteorites are heavy like this. It does have a dark surface, much like the fusion crust produced on a meteorite that goes to the atmosphere. And you see, it also has these indentations.
Huh, you can just stick your finger right.
And these indentations we call thumbprints. And that's another feature that is oftentimes produced when an object goes through the Earth's atmosphere. Was there a hole or anything like that where it was found?
No, that was really strange. Usually aren't there supposed to be like craters or...
They don't always. An object this small loses all of its cosmic velocity when it goes through the Earth's atmosphere, and it may not be moving fast enough to actually produce a crater. But you know, if this is a meteorite, it should be very strongly magnetic. So let's check this magnet. And look at that. That magnet sticks. So this, in fact, could be an iron meteorite. If it's all right with you, we'd like to run some more tests on it.
Oh, sure.
The chemical fingerprints of these visitors yield clues to their origin and type.
Basically, there are two types of meteorites. There are stony meteorites, which weigh about the same as a rock here on the surface of the Earth. Then there are iron meteorites, which are about 3 times heavier for a rock of similar sizes, and these are made up of iron metal alloys. And we think that these meteorites come from the cores of asteroids between Mars and Jupiter.
But not all meteorites are remnants of asteroids. A few are precious fragments of moons and planets. An asteroid smashes into another world. Scraps of both asteroid and target rebound back into space, some to land as meteorites here on our Earth.
Meteorites are wonderful because they give us a chance to study the geology of the rest of the solar system. We can't send spacecraft, or men for that matter, to, say, the asteroids between Mars and Jupiter yet. And we have, by virtue of these meteorites, we have samples of the planetary surfaces of those asteroids and the interiors of those asteroids. And they also help us understand the geology of larger planets like Mars. So we've loaded 2 Martian meteorites, and you can see a pocket of minerals here, and in this one, 2 minerals which we find in volcanic rocks here on Earth. But because these are Martian meteorites, we know that they therefore represent lava flows from the surface of Mars. And in fact, Mars is a very important planet to understand because it has undergone a different climatic evolution than the Earth. And if we really want to better understand our own climatic evolution, we need to study planets like Mars. And these meteorites give us a chance to do that.
A Martian meteorite lies buried in Antarctica for 30,000 years until its discovery in Allen Hills in 1984. More precious than any other rock on Earth, this sample was to become the most talked about and most carefully examined geological specimen in history. Analysis revealed that the meteorite contained exceptional characteristics of biological activity, possibly formed when Mars was warmer and wetter.
This is the Martian meteorite, Allen Hills 8401. And it contains these exciting pockets of organic material that to some looks like evidence of fossil life on Mars.
All this speculation led to frantic interest in all things Martian. Even the president joined in.
If this discovery is confirmed, it will surely be one of the most stunning insights into our universe that science has ever uncovered. Its implications are as far-reaching and awe-inspiring as can be imagined.
In the Australian outback, a strange meteorite was found. Its chemical fingerprints matched those of an object normally seen only through a telescope. That object was the asteroid Vesta, a chunk of space rock. Only the parts of it that land on Earth are meteorites. Not even the most powerful terrestrial telescopes can hope to see any detail on Vesta. At over 300 miles across, it may seem large, but in celestial terms, it's puny. In the grand scheme of things, asteroids, the millions of lumps of rock orbiting mainly between Mars and Jupiter, really are tiny. To get a good look, we need to get closer. Our first detailed images of asteroids came from the Galileo spacecraft. On its way to Jupiter, it flew past two of them, Gaspra in 1992, then Ida in 1993. Ida surprised us. Orbiting it was a tiny chunk of rock, Ida's own moon, probably a fragment of Ida itself, chipped off in some collision with another asteroid. NEAR, the Near-Earth Asteroid Rendezvous craft, is heading out on its voyage of discovery. Launched in 1996, it's making the first detailed exploration of an asteroid. It's on a 3-year, billion-mile journey. Its target is Eros, an asteroid 22 miles across and 9 miles wide. NEAR will approach Eros and circle it for about a year. Orbiting just 9 miles above the surface, the craft will measure its shape, gravity, and chemical composition. The camera will pick out features just 30 feet across. The millions of rock fragments that make up the asteroid belt are space debris that never quite unified into a planet, discouraged by the massive gravity of neighboring Jupiter. They may appear serene, drifting in orbit around the Sun, but they threaten our very survival.
Two bodies orbiting around each other are completely regular, but it only takes a third body for the system to become chaotic. When we think that in the asteroid belt there are millions of bodies, this can mean that they're essentially unpredictable.
Collision. Gravities combine and push the rocks into conflict. They set off on new paths.
There are certain regions of the asteroid belt where the planets gang up and produce chaotic behavior, and what you notice about these regions is that the asteroids are missing. Well, some of them will have been flung out of the solar system altogether, some will have gone into the Sun, and some of these will be milling around, perhaps in our own region of space, as potential threats. They could hit the Earth.
Gene Shoemaker was first to recognize that a stray asteroid may have shattered the calm of the Colorado Plateau 10 million years ago when it gouged out this crater. He believes this is an impact site. Final proof could lie in the crushed and shattered rocks scattered around.
We're now here near the outer edge of the crater in a part that was originally the rim that's collapsed in. And we found a few pieces of very strongly shocked rock, material that was close to the impacting body, and the rock has been transformed into what we call impactite. So we're going to see if we can find some more of these pieces, and it's the final proof of the impact origin of this crater. And in fact, we've got one, a dark one, right here. It's a black rock. It's been intensely crushed. It was originally a sandstone, and now it may have been partly melted. I can't tell for sure with a hand lens. But this is the kind of rock we call an impactite. Most of them have been washed away. There are just a few of them left here in this wash before it was carried over the cliff and down into the canyons and on down into the Colorado River.
"10 million years ago, this was no place to be."
If you were standing here at ground zero when this asteroid hit, and you were looking at it as it was coming, you'd first see a faint object that would start to get brighter and brighter, and finally, just before impact, the whole sky would be like the sun all over before you got squashed. If this size asteroid were to hit a city, even a very large city like Los Angeles, it would totally destroy the city. It would be completely wiped out.
Jim Scotty may seem undisturbed by this prospect. For now, he focuses on his immediate surroundings. But come nightfall, he'll be on Space Watch, a project funded by NASA and the Pentagon. He'll be looking into space, searching for asteroids that are headed our way.
One of the goals of the Spacewatch project is to discover all of the Earth-crossing asteroids that are out there. We know of less than 10% of those, maybe 100 objects altogether so far. Eventually, we'll have a full catalog of all these objects, and we'll be able to chart their courses into the future and be able to say which ones are dangerous and when they might be dangerous and which ones are the most dangerous, and we can concentrate our effort on those few objects.
Every month or so, high in the Earth's atmosphere, a small invader detonates with the force of an atomic bomb. Such blasts could easily be confused with a nuclear attack. Until recently, this information was top secret. Space is loaded with ammunition. There are over 100,000 small asteroids 100 yards across, each threatening us with the energy of 1,000 Hiroshimas. An asteroid only 200 yards across would wipe out everything within 60 miles. A 2-mile asteroid would obliterate everything within 600 miles, while a 5-mile asteroid would devastate most of the U.S. How can we protect ourselves? Alternatives include the possibility of sending craft to make just the slight deviation necessary to push the asteroid off course. And there will always be some nuclear alternative. Atomic missiles could be sent into space to intercept the invader, but new problems arise when you fragment the incoming threat with a nuclear explosion.
You don't want to blow up the asteroid because then you'd have hundreds of smaller bits that would all hit the Earth. That would be almost as dangerous as having one big object hitting the Earth. On the other hand, you may not like nuclear weapons in space because those are going to be almost as dangerous as the asteroids themselves.
Danger if we defend ourselves, and danger if we don't. The space around Earth seems full of menace.
By carrying out a survey, we can either say, yes, there is an object there that might hit us, or no, there aren't any that are among the asteroids. We cannot say that yet for comets.
For a given sized object, comets are probably slightly more dangerous because they come in faster and hit the Earth harder. An object moving twice as fast produces 4 times the amount of damage to the Earth. A lot of the comets are long period comets which come from very, very far away, and we'd only see them at most a year or two before they would be in the neighborhood of the Earth. So it's a very, very short warning time.
Fast-flying comets that seem to suddenly come from nowhere are the wildcards. They may have their origins in what's called the Oort cloud, 13 million miles away. Don Yeomans can put this in perspective.
It's generally thought that Pluto is the outermost member of our solar system, but that's far from the case. Just as an analogy, let's consider a dime, the smallest American coin. If we think of this as the size of the sun, then 2 yards away would be the orbit of the Earth. Some 75 yards away, 3/4 of the length of a football field, would be the orbit of Pluto. But the actual edge of the solar system is some 50 miles away in the Oort cloud, a cloud of comets that surrounds our sun. And that really is the edge of the solar system.
As the brightness and heat of our young sun really took off about 5 billion years ago, its radiation drove trillions of tons of material deep into cold space, where it remains frozen to this very day. Here, locked in great clumps of icy dust, are the original building blocks of our solar system. This is the Oort cloud.
Imagine a snowball about maybe 10 kilometers in diameter. And imagine that there's a lot of dirt in that snowball. That's a comet. When it is far from the sun, that's all a comet is. It's essentially unchanged from the time the solar system was started.
Larry Lebowski can replicate comets. He uses dry ice, ammonia, some organic dirt, and water. He's putting together some of the most primitive compounds that were present during the formation of our solar system. When combined, they form the dirty ice balls that we know as comets. These are the ghosts of our past, echoes of the earliest material in space. Normally, they inhabit that distant space, the Oort cloud, realm of the comets.
The Oort cloud is far enough away from the sun that so long as it's left alone, nothing very drastic is going to happen. But from time to time, the solar system passes close to another star, or perhaps to a giant cloud of gas, and the gravitational field of these objects can stir up the comets in the Oort cloud, flinging some of them out into interstellar space, and some of them in towards the inner solar system.
Some comets are deflected as they pass by the central star, undergoing just a slight change in their direction. Other comets come much closer to the sun and, in a slingshot, are turned around. Others plunge into the fires. Some comets get trapped in short orbits. Others may have an orbit lasting thousands of years and taking them out into the depths of space. Invisible for all but a fraction of their life, they may suddenly appear. January 1996. A Japanese astronomer sees a faint dot in the sky. Within 6 weeks, Hyakutake became the most observed comet in history. The frozen ice ball threw out dust and gas as it was touched by the warmth of the sun. As it flew through space, 1 million telescopes turned to view this frosty ball. Its magnificent tail stretched halfway across the night sky. But the peacock doesn't always show its tail. For most of its life, a comet is an icy nucleus, just a dirty snowball. Only when the warmth of the sun plays upon it does it start to perform. Great geysers of water vapor, gas, and dust erupt from fissures. Eventually, a huge cloud of gas surrounds the nucleus and hides it. The vapor streaming out behind these dirty snowballs can be millions of miles long, yet it is so rarefied that it could all be packed into a standard suitcase. This trail of gas and dust makes up the comet's tail, which usually points away from the sun. The dust is swept back by pressure of sunlight, while the gases are blown by the solar winds. Seen at its most magnificent in 1976, Comet West, named after its discoverer. Its dust streams out and reflects the sun's golden light as a yellow tail, while the gas is excited by the sun's radiation and fluoresces in electric blue. Alan Hale also has his name on a comet. It's the dream of amateurs to be the first to spot a new comet as it comes from out of the blue, and he did just that in July of 1995.
I was looking at a star cluster that I was observing just to pass the time, and as soon as I turned the telescope over to this particular star cluster, I noticed an object, and that, at least initially, started my suspicions that there was something going on. It might possibly have been a known comet, so the Central Bureau in Cambridge, Massachusetts has a comet identification program. It turned up negative. Well, obviously I was excited. You can't discover an object like that and know you found something without being excited about it. I've spent several hundred hours over the past 20-some years trying to find a comet that I could discover, and I never found anything, and now I stumble across a comet when I wasn't even thinking about it.
He and Thomas Bopp discovered the comet almost simultaneously.
I had I guess what one would say, an unfair advantage over Thomas Bopp in reporting discoveries. He was 90 miles from home. He was out in the middle of the desert. I was here at home right in the front yard. All I had to do was just go upstairs, log onto my computer, and send an email message.
They shared the honors, and Comet Hale-Bopp came into view in March 1997. For 3 months, the comet was a star. Touched by the sun's light and warmth, it put on a magnificent show. But it was only fleeting fame, and it headed away from the sun for another 3,500 years of dark, frozen obscurity. The sun that makes a comet's life so spectacular can also bring about its death. Not all comets manage to swing past and escape. The sun's tremendous gravity draws them in, and they plunge to dissolution. Jupiter, too, with its massive pull, also draws them in.
As comets come in from the outer Oort cloud, most of the hits are taken by Jupiter. Because it's such a large body and a massive body, it attracts comets to it. We saw this in July of 1994 when comet Shoemaker-Levy 9 smacked into Jupiter.
Like a moth to a flame, the comet was pulled into the planet. Pieces of a flying ice mountain 6 miles wide.
It was as if nature had called us up on the phone and said, okay guys, I'm going to drop 21 comets, one every 6 hours, onto Jupiter. Big ones, little ones, ones that are made of little particles loosely held together, others that are made of more solid material, all at once, over a week. And all I want you to do is watch. And watch we did.
Ground-based telescopes caught the flash from the first fireballs as the comet pieces detonated in Jupiter's atmosphere. The explosions created brilliant glowing clouds above the planet, recorded by the latest infrared cameras. From the Hubble Space Telescope high above the Earth came images of the pearly string of comets heading toward destruction. As Jupiter turned, the targets became visible to an astonished world. Disturbances the size of planet Earth bruised this gas giant.
Nature winked at us and gave us far more than we ever imagined.
Now that we've seen this destruction, perhaps the ancient fear of comets isn't so ridiculous.
A comet would come back, a king would soon die, a war would soon start, a plague would develop. And this was prevalent in cultures that really didn't interact with each other. They were thought to be signs from an angry god. They weren't celestial bodies, they were phenomena that occurred in the atmosphere to warn sinners that they had better repent, or else the next one will be a direct hit.
Drawings on Chinese tombs show comets as broom stars, stars that cleared the heavens. A coin commemorating the death of Julius Caesar has a comet foretelling the event. The same for the sack of Jerusalem.
My favorite object in the solar system is Comet Halley, not because it's the largest, not because it's the brightest, because it has the richest history. It's been scaring the hell out of people for well over 3 millennia.
The famous Bayeux Tapestry recounts the historic invasion of England in 1066 with Halley's comet overhead. When Giotto painted his Nativity in the 14th century, Over the stable, he painted not a wandering star, but Halley's Comet. March 1986, and Comet Halley approaches Earth. From out by Neptune, it falls toward the Sun, passing us en route. Brief snapshots in Halley's life before it faded into the colder depths of space. But before it departed, it was welcomed by a flotilla of craft hoping to tease out a few of its secrets. The first in the armada of spaceships were two Japanese craft. They inspected from a safe distance. Then, two Soviet probes caught the first close-up pictures. 6,000 miles from the comet seemed safe, but a blast of dust damaged the craft. Next out, Giotto, named after the artist. Its ambitious mission was to fly within a couple hundred miles of the violent nucleus. Giotto's electric eye showed the world the origin of the multi-million-mile tails. They came from a nucleus only 10 miles across. Every hour, 50,000 tons of gas and dust gushed out. But Giotto flew too close and paid the price, having its eye put out. Giotto did allow scientists to paint a picture of Halley's peanut-shaped nucleus. As it's warmed by the sun, two main fissures spew out dust and gas. Activity is greatest when they face the sun. The comet actually tumbles, taking just over 2 days to rotate. With each 76-year passage, another 200 million tons of gas and dust are lost. Eventually, all that will remain will be a dark, inactive lump.
The line between comets and asteroids is no longer as clearly drawn as it once was. The ices that were once there that made it a comet will soon become dissipated because of its prolonged life near the sun, and it will become an asteroid because it's lost its ability to outgas.
There are still enough active comets that pass us by, and the Rosetta craft built jointly by the European Space Agency and NASA will arrive at Comet Virtanen in the year 2011. Virtanen is a short-period comet coming around every 5.5 years. An orbiter will build up an overall picture of the nucleus and of the comet's activity, while a lander will touch down and drive in a spike. This spike will look for organic compounds. NASA is also planning Mission Stardust to surf the comet dust and gather a little. Aerogel, like flypaper, captures the dust. It's sent in a pod back down to Earth.
It's likely that comets brought to the early Earth the carbon-based molecules and water that was necessary for life to form. They didn't bring life to Earth, mind you, but they brought the building blocks from which life formed.
When we look at the oceans on the Earth, some scientists say that much of that was brought by comets. Other scientists say that all of it was brought by comets. But there's a good chance that when I have this drink of water, that I'm really drinking a glass of comet. And comets do taste good.
The essentials for life could well have been brought to Earth by comets, but they also have a sinister side.
These comets bring to the Earth the building blocks of life, and then subsequently you have comets coming back to the Earth and destroying the species from time to time.
The Earth is a beautiful book, and her story is told in pages of rock. And there is one painful page all over the Earth that tells that story.
"65 million years ago, catastrophe. 3/4 of all species were wiped from the face of the Earth. Associated with the rocks of that time is a thin layer of clay rich in iridium, an element rare on Earth but abundant in meteorites. Maybe a comet or asteroid smashed into the Earth and threw up a cloud of debris rich in uridium. But could any more evidence for an impact be found? Dr. David Kring went in search of a site.
We found the impact site at the end of the Cretaceous by looking at the impact ejected that had been thrown out of the crater. The closer one gets to the impact site, the thicker that debris should be. And we made a crucial discovery in the country of Haiti, where the debris was half a meter thick. That told us that the impact must have occurred somewhere within the Caribbean or Gulf of Mexico region. That led us to some geophysical surveys of a circular structure buried on the Yucatan Peninsula. And when we looked at rock samples that had been recovered from that structure, we found the unmistakable shattered rock effects of a huge asteroid collision.
They eventually mapped out a crater 100 miles wide. This was almost certainly the site of the most catastrophic event in recent history. Kring has tied up the loose ends.
The Chicxulub crater was produced when an asteroid or comet slammed into the surface of the Earth. And when that happened, the asteroid or comet itself was vaporized. It also vaporized a portion of the Earth's crust around the point of impact, melted some material, and shattered other parts of the Earth's crust. At that same time, it started the material moving and threw it out of a bowl-shaped depression, which we now call the Chicxulub impact crater.
The asteroid or comet wiped out 3/4 of all species, including the most famous victims of all, the dinosaurs.
The damage produced by an impact event of this size is enormous. Particularly locally, there would have been huge waves radiating away from the point of impact. These waves, we recognize, streamed across the Gulf of Mexico and crashed into the coast of Mexico and the United States. More globally, material ejected out of the impact crater would have been distributed on the continents of South America and North America.
Burning fragments thrown out from the impact eventually returned to Earth as incendiary missiles. Hell rained down, igniting fires around the globe.
If you were outside, you were dead. The temperature of the planet's atmosphere rose to an oven set to broiling.
In addition, much finer debris would have been ejected at very high velocities, gone into very high elliptical orbits, and eventually come raining down into the atmosphere.
The shroud of dust that girdled the globe blocked sunlight. Temperatures took a nosedive and environments were transformed.
The Yucatan Peninsula has rocks called anhydrites and limestones, and when you vaporize these, you produce sulfuric acid or carbon dioxide, and this produces acid rain and greenhouse warming.
So the dinosaurs were treated to every environmental calamity that we can possibly imagine, all at once.
All that remained were barren landscapes. Species perished in trauma at the end of the Cretaceous. The world was transformed.
Impacts of very large objects, mostly comets, have probably produced most of the great mass extinctions over the past 500 million years. Now, the important point is not just the extinctions. Following each major extinction was a burst of evolution, and new species came on the scene.
Catastrophic extinction has shaped evolution. If those species hadn't perished, would we be here today?
If a small comet the size of Shoemaker-Levy 9 hits the Earth, the danger to life would be enormous, because those clouds would block sunlight hitting the Earth, and the photosynthesis would stop, and the plants would die, and then the plant-eating animals would die, and the death would just go right up the food chain as it did 65 million years ago.
If we had an asteroid only about twice as large as the one that hit here, it would be capable possibly of causing loss of half the world's population.
From the rate that we find them, we think that there's something like 1,500 of those objects on Earth-crossing orbits.
The chances of dying from cosmic impacts are actually greater than from some airline disaster. And the reason is that when a plane crashes, it may kill a few hundred people, but when a comet or an asteroid hits, it could take out billions.
There's no question that there are going to be big impacts in the future. It's just a question of when it's going to happen.
While we wait, we may as well carry on with business as usual. Until the big one comes, we can trade on the small ones. For 3 little stones that fell from the sky, the hammer is up.
Okay, good evening, and we will seek a $500,000 opening bid. Tonight, $500,000. Bidding at $500,000. Is there interest in the lot at $500,000 is bid, and now $550,000, and $600,000 now, and now $750,000, $750,000.
I'm not really allowed to say how much I'm involved in those meteorites, or how much of them are mine, or which ones are mine, because it'll only make the price go higher and higher.
$1 million would be the next bid. $1 million is bid.
And there's a bunch of us bidding on some of those pieces.
$1,000,001 is on the phone, and $1,000,002 next.
You know, I'd just about do anything to get a meteorite. It's like my passion, my holy grail, I suppose. To me, this is a dream. This is the most fantastic, mystical, interesting things there is on Earth. They fell out of the sky.